Hello, everybody. I hope you are doing well. This is lesson number 8 in Math 100. So we have been studying about money, right? Chapter 3 in the textbook is all about money. And in the first section, section 3.1, which was lesson 7, we talked about how money grows with a compound interest, all right? So today, this is the first part of section 3.2, and that's what lesson 8 covers. And in this section, we will talk about how to save money with compound interest. And what I mean by that is a series of equal payments. Okay, so for instance, you save up a certain amount of money at the end of every month for a few years and see how much money you will have at the end of that period. That's called an annuity, and that's all about saving today. All right, so lesson 8 is about saving money, and lesson 9 is the opposite, about borrowing money. One is very positive, the other is not so positive, okay? And saving money, of course, is the positive side. Compound interest or the power of compounding will work for you. So that's what lesson number 8 is about, okay? So I hope you'll learn and save a tons of money by the end of this course maybe, all right? So let's get into lesson 8 right now. Lesson number 8 on annuities, saving money with a series of deposits. Okay, so this is what's going on. Basically, there's one, so this is section 3.2. The first half is about saving money. The second half of that section in the book is about borrowing money. All right, and so the important term here is this series of deposits. All right, so last time, you remember we had this amount of money now, okay, and it was a one-time deposit, and in the future the money grows, okay, with a certain percentage point, and that is calculated with compound interest, and it compounds every compounding period, right? And so the dollar now will be maybe worth $1.20 in a certain point in the future. The difference today is, like I said, a series of deposits. So a question we can be answering would be something like this. How much do I have to save money every month if I want to retire, say 20 years from now or 30 years from now, okay? And so many people with a full-time job do have this thing called an annuity, and that is a retirement, a saving, such as a 401k or a 403b savings opportunities. And so they have this amount of money invested. And the reason they do that is so they can save up a certain amount of money by the time they retire. And this happens usually on a monthly basis, okay? Or maybe you are saving money every month to buy a house or a car or something major in the future, all right? So the difference is, okay, you will have the amount of money coming in at a different time. So let me just give you a visual to see what we are talking about, right? So this is your money, or this is the time line, okay? So time is a continuum. And let's say you have a certain, well, we need to fix a point in time here. Let's say this is now, right? And you decide to save up a certain amount of money, all right? Let's say, well, first of all, I should say the time or the value or the worth of the money is time sensitive, okay? This is the description that basically describes pretty much any kind of money in the big context. Money is time sensitive, which means that the dollar today is not the same as the dollar a year from now or a year ago, okay? Because it is time sensitive. The value of money is time sensitive due to the interest it could earn, and it does earn, okay? So suppose you deposit $1,000 once a year for 10 years at 5% annually. You know what happens to this? Okay, so you start by depositing $1,000 today, right? Now, in 10 years, how much is it going to be worth? Okay, well, it's going to accumulate or accrues interest for 10 years, all right? So with 5% annually, do you remember the formula? It's 10 times 1.05, right? Because 1.05 is the 105%, represents 105% of $1,000. And it's going to do this for 10 compounding periods. So it's 10 times 1.05 to the 10th power, where you do this part first, okay? And that's how much you're going to end up with. But the second deposit, which is a year from today, remember you're depositing $1,000 once a year. So a year from now, you will put another $1,000. But that one, between 1 year later and 10 years later, is going to earn interest only for 9 years, okay? So this will be 1,000 times 1.05 to the 9th power. You see that? And then the next payment is going to be happening 2 years from today. You put $1,000 in here, but that's going to grow for how long? Exactly, for 8 years. I can hear everybody saying 8, right? And so the thing is, these powers, okay, these exponents are going to be different for every single deposit you are going to make. So how are we going to possibly add all the amounts? Okay, so after 30 years, after the third year, after 3 years, you'll have another 1,000 that's going to grow for 7 years. And so every one of these amounts will be different. And somehow we have to add up all these amounts at the end. How do you add them up? Well, you can do this manually by hand, which will be very complicated, right? Or you use some sort of mathematics, okay? So we are not going to go over that. It'll be great if we could. I think in classes like pre-calculus or college algebra, you learn about this thing called geometric series. And based on the formulas that come out of the study of geometric series, mathematicians can figure out how to add up these numbers with different exponents, all right? And the answer, by using a formula. And unfortunately, this is a rather complicated formula. Fortunately, you don't have to memorize that, because I am not going to have you memorize this complicated formula for a various reason, for various reasons, okay? By using a formula, all right? An annuity is what we're talking about. It is an investment plan with a series of equal and regular payments. So you have a certain amount of money that you are investing every year or every month or every quarter on a regular basis, as opposed to a one-time deposit, as you saw in the previous section. All right, so we need a new parameter, new variable. Let's let d, lowercase d, be the amount of what? Each deposit, payment or deposit. D stands for the word deposit. Okay, so D could be $100. You may be setting aside $100 every month for some event in the future, and then D will be $100. Okay, all right, so as usual, K, you had K, that's a number of what? Compounding periods per year. And remember N, the number of years. This is the total number of compounding periods. Remember, this was important, right? And then R, the rate over K. So if it's 12% monthly, this will be 1%, which is the rate per period. And so these familiar expressions will occur in this thing as well, in this formula as well, okay? Now, I'm going to write something that looks horrendous, maybe terrible, right? But again, I'm not having you memorize this one, but I do want you to use this formula, which I'm about to write, in your homework, okay? Because it is important for you to learn how to perform these complicated calculations if you are given formula, all right? So this is D times, you multiply the deposit by this huge fraction, okay? Ready for this? 1 plus R divided by K. Now you have seen this thing before. This will be 1 plus the rate per period. It's typically like 1.005 or 1.003333 or something. And then you raise it to the K times nth power. That's the number of compounding periods you saw. Now, so far, everything should look familiar. Okay, but what's new is you subtract 1 from this, and then you divide it by R over K. That's the same thing, the rate per period. So this is going to be one big fraction by which you multiply the amount of each payment or each deposit, D. Okay, so this part, of course, is the most complicated part. You should calculate this part first. I will show you step by step how to enter these things on your calculator or scientific calculator, and then multiply this by D to get your answer, okay? So I know sounds frustrating, and if you don't like numbers or calculations, this looks really scary, but do not let this intimidate you, okay? You do not have to memorize this for your homework or for your exams or your final, but you do have to use this to do a few problems in your assignments. Okay, so you do not have to memorize it, but you do need to use it for your homework. You do not need to use this for your exams. I will not provide this on your exams because you don't have to use this on the exams, just for your homework, okay? Also, know what each variable or parameter represents. So R is the annual percentage rate, right? So this is the annual rate. K is the number of compounding periods per year. And in particular, what's important is K is usually 12 because most of these annuities are done on a monthly basis, okay? And so I think that is it. N is the time in years. And that's why, this represents the number of compounding periods per year, the total number of compounding periods. All right, let me give you an example. How much will you have after 5 years? Notice here, N is equal to 5. I will write down all the information here first, actually. N is equal to 5. And you are going to save $100 every month. What's that 100? Yeah, it's a lowercase d. It's $100 every month. That means K must be 12 because you are depositing on a monthly basis. 6% compounded monthly. Monthly means K is 12. All right, and 6%, that's your R, 0.06, okay? Compounded monthly, how much interest will you earn? So this is a separate question, and I will make sure you know how to answer this type of question, because this kind of question is what I will be asking you on your homework and on your exam and on your test, okay? The test will be focusing on questions like this. How much interest will you be earning for the 5-year period? All right, so how do you do that? Here is the thing. You are trying to find your balance in 5 years, right? How much would you have after 5 years? So what you're looking for is P5, and that is $100 times this big expression. All right, what is that expression, by the way? And maybe I should have multiplied, you know what, let me move this because I should do some preliminary calculations. I like the fact that I can move this. All right, I need to have R divided by K. You see that? This happens twice in this calculation. So let's find R over K. That's 0.06 divided by 12, and that's 0.005, or half of a percentage point. So what is that? Well, that just means that every month they're going to give you half of a percentage as your interest. 1.005 is the key quantity here, and you raise it to what power? K times N. That's basically 5 years, 12 times a year. That's 60. 60 what? It's 60 months in the 5-year period, right? And that's why I refer to that number as the total number of compounding interest, compounding periods, okay? You are actually getting not exactly 6% every year, but you're getting 0.5% every month for 60 months. That's why you have a 0.005 here and 60 here. Now you subtract 1 from it. Why? Well, that's the part I was referring to when I said that advanced mathematics, geometric series. The geometric series formula requires you to calculate this exponent and then subtract 1 from it, and then you divide it by 0.005 again. That is R divided by K, okay? So that will give you the answer. I'm going to just give you the results of my calculation. The top part is going to be 0.34885. You divide it by 0.005, and the answer will be 697700. Actually, I had to truncate some digits, but it turns out you will have, after, see, here's what's happening. If you if you deposit $100 every month, or if you save up $100 every month for 5 years in an account earning interest at 6% compounded monthly, you will end up with close to $7,000. Not quite, but close to 7,000 at the end of the 5-year period. Okay. Now, here's the second part of it. Now, the total deposit, how much are you depositing? Now, for this, you don't have to worry about the time value of the money. Okay, total deposit is basically how much money you're depositing altogether. You have $100, and how many times? It's 5 years every month, so it's $60, right? So altogether, if you add up the exact amount of money that you are saving up every month, that's $100, 60 times, and that's 6,000. So the difference between the amount you will have and the amount you save up or you invest, the difference is $977. Okay, so that is the total amount of interest earned. Remember, your deposit is going to earn different amounts of interest for each payment. The first payment you make, $100 today or at the end of this month, is going to give you the most amount of interest because that's going to sit in your bank for 5 years. Okay. Or whereas the $100 you deposit 4 years from today is only going to earn interest for 1 year, right? And so how do you, I mean, in a case like this, you are depositing $100 60 different times, right? And then you are adding up all the 60 different amounts at the end using this geometric series formula. And that's what you just did, okay? And so that's how you calculate this. Now, I will be asking you questions like this on your exam, okay? But I will not be asking you to calculate this part. I will probably give you the amount of the total amount like this, okay? And then you will need to calculate the difference between how much you will be getting or how much you will have at the end of your term and how much you will be investing over that period and then find the difference. And the difference is called the total interest. Okay, so let's go back to calculating this. How do you do this operation on your calculator? Okay, here's how it works. Let me use a different color for this. Remember, the most complicated part should be done first. Okay, so I would probably start, if I were doing this on my calculator, I will start by doing 0.06 divided by 12 is equal to, okay? And that's going to give you, these are the operation keys, right? And then you will get that answer and then you multiply it by, so you use this key or the caret key, which looks exactly like this, okay? So remember this key and this key, they will do the same thing. And you take this answer and raise it to the 60th power. Okay, and so that's what will give you the answer. By the way, the equal sign here, sometimes your calculator may have another one, something else instead of the equal sign. But anyway, so this is how you will get this part. Okay, and then of course you get the answer and subtract 1 from it. You may not even have to press this enter thing. All you have to do is to subtract 1 from it. Sorry about that. Okay, and then you put your equal sign, and that's going to give you the numerator, right? And then you take that answer, which is your numerator, and you divide it by what? Well, you divide it by this number here, 0.005. 0.005, okay? And so that's going to give you, and that's going to give you the fraction, okay? And then, of course, you get that answer multiplied by 100 equals, and that will be your answer to it, okay? You want me to show you how to do this? Yeah, let's see if I can show you this on the calculator. Okay, I hope you can see this calculator here. So the first thing I did is 0.06 divided by, oops, that's the wrong one. Let's start all over again. 0.06 divided by 5, right? No, 12. And that's, of course, 0.005. That is indicating 0.5% or half of a percentage point, and that is your interest rate per month. When they say 6% monthly, this is actually the monthly interest rate that they are going to add every month, right? Okay, so then of course you add, so plus 1 to it, and that's going to give you 1.005. Okay, and then you raise it to the power of, so what is that? It's this one here. Raise it to the power of, you know, and you had already calculated 12 times 5, that's 60. And so you notice here, it's 1.005 times 60. And that's going to calculate, that's going to give you that 1.005 to the 60th power. What's the next thing you do according to your formula? Subtract 1, okay, equals, that's the numerator, the top of your big fraction. And then you divide this by, remember, r divided by k, which is 0.005. And equal sign, and that's going to give you the strange number that you see here, 69.77. All right, that is the number you multiply D by. So you multiply that by $100, and the answer is going to be $6,977.00305. But you, of course, get rid of anything that's less than a penny, and so you get $6,977.00. And that is your answer for that question. Okay, so on the back side, or on page 2, note that R divided by K is the what? Interest rate per period. All right, it's very important for you to remember that, because that comes in the numerator, a part of the numerator, and as the denominator. N times K is the total number of compounding periods. Usually it's a total number of months in your calculations. A total number, it's a total number of compounding periods, also the total number of payments or total number of deposits in this annuity context. Okay, now the thing is, you should not round any numbers in the middle of the calculations. All right, so at this point, for instance, you know, do not just round. Try to write as many digits as possible. If you cannot do this in one calculation or one sort of a flow of calculations, okay? Do not round your numbers in the middle, because if you do, your answer may be way, way off by like thousands of dollars. Use a memory function if you know how to do that, but if you don't, try to write down as many digits as possible. All right, so here's another question. This one is on retirement. Okay, so let's say your employer sets aside $100 a month. That's nice. Actually, this number is something that most times the employee decides to, you know, to tell the company on, and then that company or your employer will save up that amount of money every month. Sometimes it's matched by the company contribution. You know what I'm talking about if you are a full-time employee, but that's called matching, and sometimes that happens. But anyway, you set aside $100 a month at 8% monthly, and this of course depends on how you invest that amount of money. You know, are you investing in aggressive kind of a mutual fund, or you know, sort of a more conservative way, such as in bonds or in municipal bonds or whatever. Okay, but I mean 8% is a very aggressive and very good return. If you can put your $100 a month at 8% monthly, how much would you have in your retirement after 35 years? So that's a long period of time. Let's see if you can come up with this answer here, P of 35. That's what you're looking for, okay? And when try to write down your parameters. These what? What's R? Okay, what's K? What's N? You know, and then try to write down, I would, if I were you, I would look for this number here, because, well, sorry, it's not N divided by K, N R divided by K. You would also need N times K, because that's the exponent. That would be the number of months in 35 years, because that would be the number of times you are depositing your $100 deposits. Okay, so when you have the answer to this, come back and see if you get the right answer or not.